your feedback. Hello, Tom. Hello and welcome to the Daily Space for Friday, August 31st of 2018. I am your host, Dr. Andres Plazas, and as always, we're going to bring you a run-up of today's news from space and astronomy. So for the first story of the day, we're going to talk about star formation galaxies. So this is a press release related to some news that tells us that an international team of astronomers from Japan, Mexico, and the University of Massachusetts at Amherst have studied what they call a monster galaxy about 12.4 billion light years away from today, and they report that they have received a signal that shows us about more the dynamic properties of this galaxy, some dynamical properties that could not be proved before. So these are called some monsters galaxies because they have an extreme star formation rate, or these are called extreme starburst galaxies. And these type of galaxies are thought to be the ancestors of the massive galaxies like our own Milky Way. So this is an important finding. This galaxy is called Cosmos Aztec 1, like the Aztecs, because the instrument that they used in Chile to help find this data is called Aztec, AZTEC. So just to back up a little bit, a starburst galaxy is just a galaxy that is undergoing an exceptionally high rate of star formation as compared to other galaxies. For example, the star formation rate of our Milky Way is approximately 3 solar masses per year. However, starburst galaxies can experience a star formation rate of about a factor of 100 or even 1,000 times greater than the Milky Way. So this Aztec instrument, as I said, was built by UMass, the University of Massachusetts at Amherst, and they observed with this instrument a gas disk that is dynamically unstable, which means that the entire gas disk that makes up this galaxy is actually fragmenting and undergoing a gigantic episode of a starburst, which helps to explain the enormous star formation rate that scientists have observed. In this particular case, the star formation rate of this monster galaxy that they call is of about more than 1,000 times that of the Milky Way. And in addition of using this instrument Aztec, they have used data from the ALMA array, the Atacama Large Millimeter Submillimeter Array, that it's operated by an international consortium in Chile, including the European Southern Observatory and the National Science Foundation. And one of the best parts about ALMA is that you can see very far away galaxies with unprecedented resolution. The team has found that this galaxy is rich in the ingredients of stars, but it was still even difficult to figure out the nature of the cosmic gas in the galaxy. They have used the high resolution of ALMA, the high sensitivity to observe the galaxy, and then have obtained a detailed map of the distribution and the motion of the gas to make the highest resolution molecular gas map of a distant giant galaxy ever made, which is what we observe on the screen right here. And one of the things that one of the leaders of the study is a Japanese researcher, Dr. Tadaki, and he mentions that they found some regions of star formations actually not very close to the core, which is what we usually expect. And this is what the arrows in the screen are showing, that they're showing these concentrations that are actually far away from the core. So well, astronomers have always wondered why these giant galaxies can form stars at such a high pace. And well, in order to better understand this, they needed to better characterize the environment around these stellar nurseries. And the creation of these type of maps, of these molecular maps that we're seeing in the study today, is a very important step towards achieving this goal. Um, Yeah, so well, so using these new observations, the team members they believe that this galaxy is actually powered by this extremely heavy disk that is somehow kept unstable until then they have enough mass gas that is amassed. They say that they still don't know how much gas is collected so quickly and then kept like that, but then the gas becomes unstable, as I was mentioning before. Why is the gas so unstable in this particular galaxy? It is not very clear for the researchers they point out in their study, but they think that galaxy mergers is actually a possible cause, the phenomenon known as galaxy mergers. Because galaxy collisions may have efficiently transported the gas into a small area within the galaxy, and then that triggered this interstar formation, or it ignited this star formation. So Dr. Tadaki says, the leader researcher of this article, he says that at this moment they do not have any evidence of mergers in this galaxy. But this is one of the hypotheses, and by observing other similar galaxies with ALMA, they want to be able to unveil the relationship between the galaxy mergers and this type of monster galaxies, as they call. And that's the first story of the day. And the second story of the day has to do with Saturn and the auroras in Saturn. So these are some pictures released by the Hubble Space Telescope, operated by NASA and the European Space Agency. And well, we know that on Earth, the auroras are mainly created by particles that originally were emitted by the sun in the form of solar wind. And then when this stream of electrically charged particles gets close to our planet, then it interacts with the magnetic field, which acts as a gigantic field. And then you're gonna have a northern light or a southern light, the aurora borealis or the aurora australis, depending on which part of the hemisphere they are observed. Um, so, well, of course, as the magnetic field of the Earth is providing a protection for the environment, well, it can also trap some fraction of these solar wind particles. And then these particles that are trapped within what we call this magnetosphere, they can be energized and then follow the magnetic fields down to the magnetic poles. Um, After that, of course, they interact with molecules or with atoms of oxygen and nitrogen in the upper layer of the atmosphere, and then this gives origin to these flickering lights, colorful lights that we have seen. I have actually never seen them myself in person, and that's one of my goals in my bucket list. So that'd be pretty cool. But the point of this news is that these auroras are not unique to our home planet. So other planets in our solar system have been found to have similar auroras, and one of them, among them, are the four giants in our solar system: the gas giants, such as Jupiter and Saturn, and the ice giants, Uranus and Neptune. But in the case of the atmosphere of these gaseous planets, the atmosphere is dominated by hydrogen. So the interaction that it creates with the particles of light actually emits light in the ultraviolet wavelengths. So in order to be able to detect these ultraviolet wavelengths, you cannot do that from the ground, and that's why you need to do observations using a space telescope such as Hubble Space Telescope. So these observations were coordinated with the grand finale of NASA's Cassini orbiter from last year, when the spacecraft simultaneously probed the auroral regions of Saturn. And this data from the Hubble Space Telescope allowed scientists to learn more about the magnetosphere of Saturn. The images show a very rich variety of emissions in a highly variable localized features. And then researchers say that this variability in the Saturnian auroras is influenced by both the solar wind and the rapid rotation of the giant planet, which is about 11 terrestrial hours, which is fast, of course, compared to a terrestrial day. Um, Yeah, so that's this is the second story that I wanted to talk about today, related to these beautiful auroras in Saturn. So what you can see on your screen is the actual image in the ultraviolet wavelength, but the image of the right is actually a superposition, of course, of an optical image and the aurora in the ultraviolet. So it looks cooler. And for the final story of the day, well, maybe Dr. Gay already talked a little bit about this, but as you know, right now in Vienna, in Austria, the General Assembly of the International Astronomical Union, the 30th General Assembly of the International Astronomical Union, is taking place. Actually, it is coming to an end. But one of the things that people do in these assemblies is talking about politics at the same time as they talk about science, and we talk about definitions, and we talk about classifications, which are important things to do in our field. And one of the things that they were going to vote about today was whether to rename what we call the Hubble law into the Hubble-Lemaitre's law. So I figured that I wanted to talk a little bit about what's the story behind this, and well, we're gonna back up a little bit to the theory of general relativity in 1916, and then Albert Einstein came out with his new theory of gravity, and then he actually applied this whole theory of gravity to the whole universe, to the universe as a whole. And then the theory was telling him that in a universe that is not empty, a universe that has matter, then you should have some dynamism. The universe actually should be expanding or contracting. However, Einstein was not happy with the solution by his own theory, and he actually wanted to align the results of his theory with the prevalent view of the time, that the universe was static. And he therefore introduced a term in his equations to actually make the universe static. But then, meanwhile, in Russia, then there was this guy called Alexander Friedman, and he actually took the same theory of general relativity, but he didn't care about letting the universe being static or not. And he actually found out that the theory of general relativity produces solutions where a universe could be expanding or contracting, which was like unheard of at the time. So actually, Friedman showed these results to Einstein, and Einstein told him like, yeah, this is interesting, but actually this is not how the world is actually. So Alexander Friedman was like not happy with that, but that's what it is. Then unfortunately, he died in 1925, and why unfortunately? Because actually he was right. Then came this other guy, Georges Lemaitre. He was also a Catholic priest from Belgium, but he was a very good cosmologist, and he was able to derive again the solutions by Friedman, and then he found out that the universe was actually could actually be expanding or contracting. But in addition to this theoretical result, Georges Lemaitre knew about the work of an American astronomer called Vesto Slipher, and this astronomer, since actually 1912, had been measuring the spectra of galaxies and had found out that most of them were shifted towards the red. So this is what we call the redshift. So Georges Lemaitre actually put together his theoretical result and the observations by Vesto Slipher, and then he said that these observations by Vesto Slipher were an indication that all these galaxies are actually looking on average red, is because the space-time itself, the universe itself, is expanding. So he wrote this in a paper in 1928 in French. It was published in a journal in Belgium. And I don't think a lot of people read his paper, but he clearly described what we know of today as Hubble's law, which says that actually if you measure the velocity of all these galaxies that are on average redshifted, and then you also measure the distances of those galaxies, and then you put those numbers together in the same plot, then you're going to find a straight line. So that is to say that the distance of the galaxies is the velocity of the galaxies is proportional to the distances that we find, and the constant of proportionality is what later has become as Hubble's constant. And so why is it called Hubble's constant and Hubble's law? Well, then in 1929, in Mount Wilson in Pasadena, in California, in the 100-inch telescope, Hooker telescope, Edwin Hubble was able to reproduce the observations by Westersliffer, and he was also able to rederive Hubble's law. And so he did a diagram, and then he found out that yes, this is a straight line. He provided an estimate for the Hubble's constant, and then he published his result. And then, of course, then from now on, people actually started knowing this result as Hubble's law. So he didn't publish his result by himself. He has a lot of help from a lot of people in Mount Wilson, and in particular, one of the persons that actually helped Hubble, and usually is not mentioned a lot of times, is Milton Humason. And the story of Milton Humason is actually very interesting because he started being one of those mule boys helping to bring material to the top of Mount Wilson in mules. Then he became a janitor, but then one day he decided to actually volunteer to help in the observations. And then actually George Hale, the director of Mount Wilson, realized that this guy was very smart, and then he hired him as an official staff of Mount Wilson, which was something unheard of because this guy didn't even have a high school diploma, much less a PhD. Eventually, he ended up being the personal assistant of Edwin Hubble, and then they even published a paper together in which they explained their observations and they explained Hubble's law. So just to finish a little bit the saga and coming back to this, the Royal Astronomical Society in England actually asked Lemaitre to republish his paper in French in English, and then Lemaitre was like, okay, sure. So he did it, but then in this new paper in English, he left out that paragraph where he actually was explaining Hubble's law, and then he was saying, then somebody did an investigation, and then he saw that in letters Lemaitre wrote, well, actually, I left that out because Dr. Hubble already published this with better data, so there was no point. And then it got lost in history, and then people just stopped calling Hubble's law the Hubble-Lemaitre law. So until today, now yesterday actually, the International Astronomical Union put forward this notion, suggesting that we rename this law. So they actually did the vote this time, but this time they want to allow other members of the International Astronomical Union who couldn't attend Vienna, like myself, to actually vote electronically because they don't want to have a controversy like the one that we had with Pluto. Like in 2006, people at the International Astronomical Union General Assembly decided to rename Pluto. But then a lot of people were not that happy with that, and they were pointing out that there were only just a few astronomers there, according to them, and it wasn't that clear. So now they're doing something similar, but they want to extend the vote to give about 30 days or so to people in the world to propose their electronic vote. And yeah, let's see how this played out. I just figured I wanted to tell you about this story, which it is fascinating to me because this is a story that, of course, when I learned cosmology, I just learned about Hubble, and that's it. And Hubble was the only one who discovered this in Mount Wilson, and everybody was happy. But then and this is not unique to astronomy, of course. This happens along the history of science. A lot of the contributions of a lot of people are always left out, and this happens. But if there are occasions where we can actually try to maybe do some justice to the people who contributed to an idea, then in the face of evidence that, in my opinion, maybe we should try to do it. And this is an important debate because, for example, there are other instances of science when now science is not done only just by one person. You have collaborations of thousands of people, like the discovery of the Higgs boson. And then some people may say, like, well, it wasn't just not only these three people who proposed, who wrote the paper, right? It was thousands of people who actually made this happen, and maybe we should have given the Nobel Prize to everybody. But yeah, I think it's an interesting discussion, and also let us revisit the history of many of these phenomena that are important for in the history of cosmology. I also like history and cosmology. But there you go. That's what I wanted to mention today. I don't know what the results of the vote yesterday are. Maybe we can ask Pamela next week when she comes back, because I think it was in a closed session, as far as I know. So it would be interesting to hear her thoughts on that. And that's it for today. And now I'm gonna see what all of you have to say. And as usual, go back to the comments and say hi to everyone. So I already said hi to UHE Cosmic Rays, Paranor, Tom, hello. Hello, Guido. Hello, Hani. Hello, Graham. Um, Hani's asking, how long did it take people to accept Hubble-Lemaitre's law? It seems like a big shift in thinking about the universe, especially in the lay public. You are correct. It didn't took like that long. It took like a couple of more years, like by 1931. So Hubble published his paper in 1929. Lemaitre published his paper in 1928. Hubble in 1929. He even published another paper in 1931. And then people were starting to recognize more and more that in the face of evidence, this is what actually was going on. Albert Einstein wasn't that convinced at first. As I said, he still believed in a static universe, and that's why he put this extra-termicist theory, which he called the cosmological constant. But then eventually, Albert Einstein came to the United States. He came to Pasadena. He came to other observatories in the United States and talked to other people who were doing observations. And then, in the face of evidence, then Albert Einstein was convinced. He put aside his prejudices, and then, as many of you know, he called the cosmological constant the greatest blunder of his life, because he could have predicted the expansion of the universe. And this is one of the most important observations in the current cosmological model that we have today. There are three basic observations that support the cosmological model from today, the theory of the Big Bang, and one of them is the expansion of the universe. The other two being the cosmic microwave background and the relative abundance of light elements in the early universe, like hydrogen and helium and lithium and deuterium. Hello, Uncle Bill. Paranor points out that echoes Darwin and Wallace. Yes, it happens. Yeah, in other fields, and there is a lot of stolen credit, but none of it is intentional. All this Paranor points out. Hello, Magnus. By that time, so Hani is asking, was Hubble created, the Hubble Space Telescope, I assume, to confirm the Hubble-Lemaitre law, or was it already fully accepted? It was already fully accepted, actually. So the idea of a space telescope was theorized by Lyman Spitzer, actually, back in the 40s, in 46. And then a lot of decades had to happen for Hubble to make it into space. But by the time people already accepted the expansion of the universe. And it is true that one of the key science objectives of the Hubble Space Telescope was to measure the Hubble's constant, the rate of expansion of the universe. And if you Google the Hubble key project, that's one of the first measurements, precise measurements that the Hubble Space Telescope helped to point out, to point down. Okay. Okay, everyone. Do you have any more comments? Hello, Mello. I think we're about to finish our daily space run today, but of course you always have access to the videos on our YouTube channel. On Twitch, they're there, but just for a few days. But then if you go to YouTube, then you should be able to watch our shows over and over again. Um, okay, so yes, I'm sorry. We usually have daily space this week. These past 2 weeks we have daily space at 1 p.m. Central Time. That's my time, but usually we have it at noon Central Time. So next week we should be able to come back to the regular time, if I'm not mistaken, but let's gonna confirm that. On Monday, we have Labor's Day in the United States. So in many parts of the world, it's on May the 1st, but in the United States, it's in September. So I'm not sure if we're gonna have a daily space, so stay tuned. Maybe Pamela can confirm. Denise of Earth asks, may I ask how you gather the stories you talk about? So most of the time I get an email from the American Astronomical Society, a press release, and that's very convenient. I get an email in my mailbox, and that's where most of the stories come from those press releases. But sometimes the days are very slow, so I just go to the archive, what is known as the archive, AstroPH. This is where scientists in astronomy post their papers. Some of them are peer reviewed, some of them they post them before peer review, so it's good to check in the fine print. It says we have submitted this paper to peer review or we have not. So it's good to be aware of that. So and other times I just look on, when I'm looking on social media, a story that I like. The story about Hubble Lemaitre law, well, my area of expertise is observational cosmology, so I was aware of this, and it came from the electronic newspaper of the International Astronomical Union, in which Dr. Pamela Gay is editor-in-chief. So yes, so most of the time there are press releases that I get into my mailbox, so other times I look to actual papers, go directly to the papers or just on social media and then see what I find interesting, and I hope that you also find interesting. Hello, Mello, first timer, welcome. Welcome. And yeah, as I said, well, please check out our channel in Twitch, our YouTube channel. Please go to CosmoQuest.org if you want to help us map the craters of the solar system and help us with citizen science. That's great. And yeah, okay, well, so thank you so much, everyone, for watching. This has been the Daily Space. It's a production of CosmoQuest, created by the Astronomical Society of the Pacific. And our goal is to put science in your brain. If you like this show, please give us a follows. The follows are free. And if you want to sustain our efforts, please consider subscribing. Every bit also helps. And the Daily Space will be back next week, and every weekday at 1 p.m. Eastern, 10 a.m. Pacific, and 6 p.m. London. Please check back. I'm not sure if we're going to have a Daily Space for Labor's Day in the US. I don't have that information yet, but we may or may not. But for sure, we're going to come back on Tuesday. So have all of you a great weekend, and thank you so much for listening. Adios. Bye bye.